Hey, welcome to the channel. Today I have a little story to tell you. A while back, about a week ago, a guy asked me, "Hey Josh, what happens when you turn on a computer? Like, what happens between pressing the power button and going to YouTube and watching this video and subscribing? Like, what happens?" And let me tell you, as I told him everything. I let him in on all the insider secrets. I let him know exactly what's up. And I want to show you that same process. Well, tell you. I'm not having a picture show today. So, the very first thing that happens when you turn on your computer is it goes through and loads the basic input-output system. The BIOS, as I just said, is located on a chip on the board of every single computer. This applies to your smartphone, your set-top box, your laptop, and most notably, your desktop computer. Hopefully it's in a case and hooked up. So on this board, let me point to you the chip. There it is. It says MBIOS. That is on my little Gigabyte H310 MA Micro ATX board if you're interested. This one chip loads the code, and it loads this basic input-output system. It's also called the program. It's called a program. It's a program that it executes code. So this code runs something called the power on self test, also known as the post. The post goes through everything. It goes through RAM. It looks at RAM. It's like, hey, are you valid RAM? Are you made of potatoes? Is anything shorting out? Hey, CPU, are you overheating immediately, or are you going to be okay? You good? Looks at the graphics card and say, hey, are all these pins in here? Is pin 43 connected? Yes. Is pin 44 connected? Yes. Is pin 45 connected? Yes. And so on. It looks at the hard drive and says, hey, are you formatted correctly? You might be electrically intact, but like, can I talk to you? Is everything good? It'll talk to our little audio chip and be like, hey, is the audio part of this working? Can I output some beeps, in case I have a problem with my post, which frequently happens. I notice this a lot with laptops, just because they get beat up a lot more, is they'll have beeps and you'll have to look at them and be like, okay, I need to reset the RAM, or I need to do this to it. I need to do this to it. The post and beep codes let you know what's up with your computer. So that post goes through everything, and if it passes, it goes on. If it fails, more than likely it will not go on, except for special instances like maybe the keyboard doesn't work. The computer will hold up and be like, whoa, there's no input device. Now what? Okay, let me go on with my life. Like, you're not going to do anything about it. You can't tell the computer to go on if there's no input device. So the next part is once it completes this post, it will write a log. It has a little battery so it can keep some memory and some settings. It will write a log and say, hey, I booted successfully on this date. And then it will start looking at the boot devices. The boot devices are, in this instance, it has an M.2 drive it can look at. It has some SATA ports it can look at. It has some PCI Express that it might be able to boot to. Maybe some USB stuff, if you have like a USB boot disk. It's looking for stuff that has storage, that can load code, and once it finds something, let's say from here, it goes and it finds a hard drive. Hard drive's like, hey, I'm here, I'm formatted. Here is my master boot record. So once it gets into the hard drive, which it will instinctively do, once it passes post, it is looking for something to do. It's looking for something to load into. It's looking for maybe a Windows partition or something. It looks at the hard drive and says, hey, you have a master boot record. In that master boot record, it says that there's a bootloader that controls whether or not I boot into Mac or Windows or Linux or whatever else your computer's running. Those are the main three operating systems. And then once it finds something in there that says, the bootloader loads, it's like, hi, I'm the bootloader. I'm going to load into the Linux kernel, or maybe the Windows kernel. The kernel is, by definition, the central or the most important part of a thing. And the kernel of our operating system is actually, it can be thought of as the bottom layer. So when you initially start Windows, Windows is saying, it does its own little post. It looks through the devices and says, is this working? Is this working? Is this going to cause an infinite loop? Like, it goes through all these checks. Once it sees it's in a good environment, it starts loading up drivers. Drivers are it's literally, it can be thought of as driving a car. It's the person in between, it's the person that allows the vehicle to get somewhere. So the drivers in an operating system is the software code that allows something like a mouse to do what it needs to do. The mouse is throwing a bunch of raw data like, hey, I moved up and down, I moved left and right. The drivers are the things that accept that input and translate it into something that the operating system can work with. In Windows, it's moving the mouse up and down and so forth. A great example of like a difference of drivers is graphics cards. All graphics cards support this generic talk to mode, where you can put in this buggy, low resolution looking thing. Basically enough to get you going to install the actual graphics card drivers that allow it to do ray tracing, run 1080p, 4K displays, multiple displays. Like all these advanced features are supported by the drivers of the graphics card. The drivers are the in-between between Windows and your RTX 2080 Ti. These two talk through a specific interface, and it's called drivers. It might run on like the PCI Express and then drivers and etc. Drivers allow your computer to talk to stuff because when you load your computer, Windows has to understand natively what all these devices are. Initially, it understands them generically, but later installs actual proper drivers for it. So there's a little bit more about drivers than you probably ever wanted to know. So once it loads all these drivers, the Windows kernel will start loading more of Windows. Once it says, I'm in a good environment, it will load your desktop. Your desktop is what you know to be Windows. It involves all of the Windows. It involves all the applications and services that are running. It involves a start menu. It involves the clock being displayed. Basically that screen that you see when you turn the thing on. And if you're working with, like, let's say a phone, it'll be that home screen, like where you see all the apps. Or if it's Mac, it's like the desktop as well. So what's happened here is the operating system has talked to everything below it. Everything is fine. Everything is talking back to the operating system, and it's giving some control over to the user to do whatever it wants to do. It'll eventually get to this sort of pseudo standby state where it's waiting on you to click something. Open up an application, perhaps. In Windows, it's applications. Mac, it's smartphones, it's apps. A Mac, they do their own thing. I don't know. If you have a Mac, no offense to you. So once you open up an application, the computer says, I need to open up Google Chrome. Let's load some more information to RAM. All this time, Windows has been loaded to RAM. Now your application called Google Chrome is going to get loaded to RAM. Once it's in RAM, it will start showing up on your display, basically, and you'll see it. You'll see Google Chrome, and you can type in YouTube. After that, all the steps are mainly network related, which I'm not going to go into this video, but all that to say is that your computer is going from this off state to a basic core state to a Windows state, and then now it has this ability to talk to the outside world, which is a truly marvelous thing and should not be overlooked in the slightest. But getting to that point of being able to talk to the outside world, there's a lot of stuff that goes on. And it'll talk to YouTube, it'll say, oh, you were looking up Josh Parsons, here's the video of how a computer starts up, and And it'll start feeding the stream data, and you'll start seeing it displayed on your graphics card. And that's about it. It's really, I want to say, as simple as that. There's a lot of stuff involved, but if you think of it in a layered pattern, it'll allow you to easier be able to troubleshoot, diagnose, understand all of it. A key thing could be maybe you don't have the graphics card installed. So there's a problem with the lower layer of Windows that's preventing you from playing Fortnite in the best possible settings. In the network realm of stuff, this is called the OSI model. But in computers, it also is built on this sort of layered structure. It starts with the BIOS. It goes to, it passes a post. It looks for an MBR. MBR is basically the master boot record. It's like a table of contents for a drive. It finds a bootloader, which is something that can allow it to pass on code. Once it's in that bootloader and it finds a partition that it wants to load data from, it will load that data to RAM. That data starts to get executed. At this point, we're in the Windows kernel or your equivalent, whatever you're running. Once you're in the kernel, you load some basic device drivers. You allow the keyboard, mouse, display, etc. to talk to each other and to the core system. The core system being the kernel. And then once the kernel is fully initialized, it will start loading some more secondary stuff like processes, desktop environment, Windows services. And then once all of those are loaded, you're in that sort of, the computer's on, you can click stuff. When you click stuff, it will do stuff. We all know that when we turn our computers on, there's always like that awkward 2 minutes where everything is there, but it's not working. This is that in between. And you click Google Chrome and you go to YouTube and it does some network stuff, which is beautiful because it's talking to the outside world. And you watch this video and that's how that all happened. Which is just truly amazing to see it all happen in the span of nowadays 60 seconds or less. All of that happens and it's amazing. And after I told this guy, he's like, wow, I never thought that so much would happen when I turn on the computer. And I was like, me neither. It's amazing. And this process has been going on for probably over 30 years now because, you click, probably over 30 years now. We've been using a basic input-output system for a long time. I just tore apart a Tandy computer a while ago, and on it, I found a BIOS chip. So if they were making that in 1986 or something, I'm amazed that this process still works and we're still using it, and we're always improving upon the components. So we're always making like better hardware. We have the i7 Super Extreme. We're always making like better software, Windows 10 Professional. We're making better motherboards of like, I don't know. Truly, I think this is amazing, but there's better ones out there. We're always making better stuff for every layer. We're always making a better Google Chrome. We're always making a better YouTube. But the same process of going from up the layer it's still there for over 30 years. That's amazing. And who knows, maybe it'll change in the future, but if it works, it works. So I thank you guys for watching this video. I hope you've learned something from it. I know when I explained this to this guy, he was like, wow, I learned something today. So I definitely wanted to share that with you. Thank you for joining me, and please subscribe. Hopefully I can teach some more better, cool stuff in the future. Another thing is, I want to encourage you to ask yourself these questions. Ask the loaded questions of what happens when I turn on the computer, because who knows, it might spark you on a lifelong adventure of technological discovery. It did for me. Thanks for watching. Goodbye.